Hey everyone, it's Adam, and in this video I'm going to show you the progress I've made on the PSPi 6. So this project began back in 2021 when I was making the PSPi 05. I originally planned to also release the Compute version, which would have basically the same features as the Zero, but run on only the CM4 modules, but the chip shortages ruined those plans. I then tried swapping to different components, and I made a few prototypes trying to work around the shortages, but that got really expensive really fast, and I put the project on hold. That roadblock gave me some time to think about the project, and as a result, I changed the plan a bit. Instead of making separate boards for the Zero and the Compute, I'll make a single board and then make a separate carrier adapter for the CM4. This makes the job a lot easier for me because I don't have to repeat work when I want to tweak the design on it. I recently got the first working prototype in, so let's get a look at it. So here's what I received from the manufacturer. This is the main board and this is the CM4 interface. So for those of you that are new to the project, this is a board that's designed to fit into the PSP shell without making any changes to the shell. And it lets you use a Raspberry Pi as the brains. I started this back in 2016 with the Rat's Nest, and this has gradually evolved into what it is today as I've learned more about coding and PSP design. The last version was version 5 and this one builds on it. I have a few videos in a playlist linked below if you want to check them out, and I'm going to compare this board to the most recent one, the version 5. I'll start with the display color depth. The 05 used 6 bits for each of the colors red, green, and blue, and this new board uses 7 bits for each color when using the Pi 0 and 8 bits for each color when using the Compute module. This gets rid of some of the banding that you see when high color depth images or videos are displayed. I also modified some of the LCD components so that it draws less power when the screen is off. When dimmed to 0%, it completely shuts off every bit of LCD circuitry and saves maybe 10 or 20 milliamps. It's a small reduction when compared to the amount of power the Pi uses when it's idle, but it was just a simple change that only costs a couple pennies to add, and it allows the battery to last a little bit longer in some situations. The LCD backlight on this is still dimmable, like it was in version 5, and you can cycle through 8 brightness levels when pressing the display button. The maximum brightness on this is slightly higher than previous boards, and the minimum is slightly lower, and everything is still controlled by the microcontroller. That microcontroller is also a little different from the previous board. I originally used an Atmega 328P, which is the same chip used on Arduino boards, and this new one is an Atmega 8A. It's functionally identical in this situation because I don't need all the extra features that the 328 brings, and the cost of the chip goes from $3 to about $1. I also added a new battery charger, which charges the battery faster and produces basically no heat when it's charging. I did this one mostly because the CM4 produces so much heat that the internals were getting a little bit hot when charging. Basically, all the power circuits got a major overhaul, and I'll probably make a video dedicated to explaining just those changes at some point. I made some changes to the board shape as well, and it's a little bit closer to the shape of the original PSP board. The speaker connectors are now in the same position as the genuine PSP, so there's no rerouting needed when hooking those up. This new board has a standard looking 40-pin Raspberry Pi female connector on it, and it works with all standard 40-pin Raspberry Pi boards. There's a lot more going on here though, and it doesn't exactly match a standard Raspberry Pi connector. Normally there's 8 pins that are used for ground, but only 2 pins are used for ground here, and the other 6 are used for better audio and better display coming from the Compute module. I made another major change to this header, and it's that it's now flipped compared to the previous boards. The Pi 0 used to mount with the pads facing down so that I could use them to interface the USB and the SD card connections, but it now mounts with them facing up, which means that you can now use pre-soldered Raspberry Pi boards. Now, installation is as simple as just plugging it in, so the whole process is a lot easier. The tests on the PSPi 6 are going really well, and even better than I expected considering how many changes I made. Most of the basic functions are now up and running, and I've even added a software volume adjustment. The mute button now mutes both speaker and headphone audio, and the initial battery calculation code is up and running. The volume up and down buttons adjust volume on both the headphones and the speakers, and I'll eventually add an indicator similar to the one I have for brightness that'll tell you what the volume level is as you're pushing the buttons. I have both RetroPie and Laka up and running. RetroPie is great, and the minimal interface gives decent playtime because it isn't doing too much in the background when it's idle. I also solved the problems that were keeping Laka from working, and it looks great on the PSP. The one major downside to this though is that the interface uses a ton of processing power, and it drains the battery a lot faster. There are still a few kinks to work out. I've been tweaking the audio filter quite a bit, and the goal is to have a little bit of bass on the headphones, but basically none on the PSP speakers because they just can't handle it. I have it close, but there's a little bit left to do. I also haven't quite nailed down the best way to connect the Pi Zero's USB to the PSPi board. The new mounting position means that I can't easily connect the USB data pads on the bottom to my board, and now I have to work out a better solution for it. I got a few ideas I'm going to try, and if you have any thoughts, I'm all ears. So that's about it for now. You can follow along with progress on EasyEDA, GitHub, or Discord if you want constant updates. Or you can follow here on YouTube if you just want occasional ones. You can also order one of these boards from the manufacturer at any point, but be aware that I'm still testing things, and I'm sure there's going to be more changes before I call it done. Some assembly is also required if you decide to order from them, and you'll have to manually solder some connectors to the board and manually upload firmware to the microcontroller before you can use it. And finally, this is an open source project, and I'm doing this solo, so if any of you want to contribute, I definitely welcome it. Whether it's by helping with the design, coding, testing, or just recommending improvements, I'm happy to hear what you have to say, and I'll accept any assistance. You can also help by spreading the word and sharing the project with others. And if anyone out there is able to contribute monetarily, that's also greatly appreciated. I really can't put a dollar amount on the number of hours I spend testing and coding, but the prototypes are very expensive, and I have to be very slow with testing and modifying them. The more prototypes I can order, the faster I can test and make improvements. At the end of the day, I'm doing this because I love it, so don't feel any obligation. Your support would just help me get there faster. I have links in the description if you want to check them out. Alright, thanks for watching, and I'll share more soon.